Section 1. Introduction. Our Sun, a star we often take for granted, is the anchor of our solar system. It provides the light and warmth that sustains life on Earth. But like all stars, the Sun has a life cycle. It will not shine forever. In about 5 billion years, our Sun will enter its final stages. It will transform into a red giant, a celestial behemoth that will dramatically reshape our solar system. This transformation will be a slow and gradual process. It will unfold over millions of years. This cosmic shift will have profound implications for every corner of our solar system. The inner planets, including Earth, will face an apocalyptic fate. The outer planets will experience radical changes in their temperatures and atmospheres. Even distant moons, currently locked in ice, may find themselves bathed in the warmth of a dying star. The Sun's transformation into a red giant is a story of cosmic change on an unimaginable scale. It is a story of destruction and creation, of loss and renewal. As we explore this future, we gain a deeper understanding of the forces that govern the cosmos and the delicate balance that sustains life. We are reminded that our place in the universe is both precious and fleeting. In this essay, we will embark on a journey through time and space. We will explore the Sun's final dance as a red giant and its impact on our solar system. We will witness the vaporization of planets, the shifting of orbits, and the potential for new life to emerge in unexpected places. This is a story of cosmic upheaval, but it is also a testament to the enduring power of change and the boundless possibilities of the universe. Section 2. Timeline. The Sun's transformation into a red giant is not a sudden event. It is a gradual process that unfolds over billions of years. The first stage of this transformation involves the Sun slowly expanding and cooling. Its outer layers will swell, and its core will contract, leading to a decrease in surface temperature. This cooling, however, is relative. The Sun will still be incredibly hot. Its luminosity will actually increase, bathing the solar system in even more intense radiation. As the Sun continues to expand, it will reach a critical point. Its outer layers will engulf the innermost planets, Mercury and Venus. These planets will be vaporized, their material absorbed into the Sun's expanding atmosphere. Earth's fate is less certain, but it will likely be rendered uninhabitable. The intense heat and radiation from the red giant Sun will boil away our oceans, scorch our continents, and strip away our atmosphere. The Sun will reach its maximum size as a red giant in about 7 billion years. At this point, it will be hundreds of times larger than its current size. Its outer layers will extend beyond the current orbit of Mars. The red giant Sun will then enter a period of instability, shedding its outer layers into space. These ejected layers will form a planetary nebula, a glowing cloud of gas and dust that will enrich the interstellar medium. Section 3. Inner Solar System. The inner solar system, home to Mercury, Venus, Earth, and Mars, will be dramatically reshaped by the Sun's transformation into a red giant. As the Sun expands, its increasing luminosity will heat the inner planets to extreme temperatures. Mercury, the closest planet to the Sun, will be the first to experience the full force of this cosmic furnace. Its rocky surface will melt and vaporize, and its thin atmosphere will be stripped away. Venus, with its thick atmosphere and runaway greenhouse effect, will also succumb to the Sun's heat. Its surface, already hot enough to melt lead, will become even hotter. Its atmosphere will be superheated and eventually stripped away by the Sun's expanding outer layers. Earth, our home planet, will not escape unscathed. The oceans will boil away, leaving behind barren, parched continents. The atmosphere will be stripped away, exposing the planet's surface to the full force of the Sun's radiation. Mars, the fourth planet from the Sun, may fare slightly better. Its greater distance from the Sun will offer some protection from the worst of the heat. However, Mars will still experience a significant increase in temperature. Its thin atmosphere will likely be stripped away, and any remaining water ice will sublimate, leaving the planet a barren, desolate wasteland. Section 4. Asteroid Belt and Jupiter. The asteroid belt, a region of rocky debris between Mars and Jupiter, will be significantly altered as the Sun evolves into a red giant. The increased radiation from the Sun will heat the asteroids, causing some of them to vaporize. The remaining asteroids will experience changes in their orbits due to the Sun's changing gravitational pull. Some asteroids may be ejected from the solar system entirely, while others may be drawn inwards, posing a potential threat to any surviving planets. Jupiter, the largest planet in our solar system, will experience a dramatic transformation as the Sun expands. Its massive gaseous atmosphere will expand and heat up, potentially becoming a vibrant, swirling canvas of colors. Jupiter's moons, many of which are icy worlds, will also experience significant changes. The icy surfaces of these moons will melt, creating vast oceans of liquid water. Europa, a moon with a subsurface ocean, may become a prime candidate for the emergence of life. Jupiter's increased gravitational pull, due to its expanded atmosphere, will disrupt the asteroid belt, scattering asteroids and potentially sending some hurtling towards the inner solar system. This cosmic billiards game will reshape the structure of the asteroid belt, scattering its debris and potentially creating new families of asteroids with altered orbits. Section 5. Outer Solar System. The outer solar system, home to gas giants Saturn, Uranus, and Neptune, will also feel the effects of the Sun's transformation. While these planets will not be engulfed by the expanding red giant, they will experience significant changes in their temperatures and atmospheres. Saturn's rings, composed primarily of ice, will melt and vaporize, creating a diffuse halo around the planet. Saturn's atmosphere will expand and heat up, potentially becoming more dynamic and turbulent. Uranus and Neptune, the ice giants, will also experience warming. Their icy mantles may partially melt, leading to the formation of vast, deep oceans. Their atmospheres will become more active, with increased storm activity and potentially even the formation of new moons from the coalescing material. The Kuiper Belt, a region of icy bodies beyond Neptune, will also be affected. The increased radiation from the Sun will cause many of these icy bodies to sublimate, releasing gases and dust into space. This could lead to the formation of a tenuous, extended atmosphere around the Sun, stretching far beyond the orbits of the planets. Section 6. Titan. Titan, Saturn's largest moon, stands out as a unique case in our solar system. It is the only moon known to have a dense atmosphere, and it is rich in organic molecules, the building blocks of life. Currently, Titan is a frigid world with a surface temperature of -179 degrees Celsius. Its surface is dotted with lakes and seas of liquid methane and ethane. However, as the Sun evolves into a red giant, Titan's fate may take an unexpected turn. The increased radiation from the red giant Sun will warm Titan's atmosphere, causing its surface temperature to rise. The frozen methane and ethane will melt, creating even larger bodies of liquid hydrocarbons. As the temperature continues to rise, some of the methane and ethane may evaporate, creating a denser, more Earth-like atmosphere. The increase in temperature and the presence of liquid water could create conditions conducive to the emergence of new life forms. These life forms would likely be very different from life on Earth, adapted to a world rich in hydrocarbons and with a nitrogen-dominated atmosphere. Section 7. Conclusion. The Sun's transformation into a red giant will mark a dramatic turning point in the history of our solar system. The inner planets will be consumed, the asteroid belt will be reshaped, and the outer planets will be transformed. Yet, amidst this cosmic upheaval, there is potential for new beginnings. The moons of Jupiter and Saturn, currently locked in ice, may become havens for life. Titan, with its unique atmosphere and rich organic chemistry, may witness the emergence of life forms unlike anything we have ever seen. The Sun's final dance as a red giant is a reminder of the impermanence of our own existence. It is a testament to the vastness of the cosmos and the power of change. As we look to the future, we can only speculate about the ultimate fate of our solar system. Will life find a new foothold in the outer reaches of our Sun's influence? Will the seeds of life, carried on the winds of a dying star, take root in distant star systems, seeding the galaxy with new possibilities? These are questions that will continue to captivate our imaginations as we explore the universe and our place within it.